All right, what's up? Let's take a look at finding second, third, fourth, fifth derivatives, basically higher derivatives. And we'll work several examples where we find all the higher derivatives. We'll find second derivatives and evaluate them. And we'll find the second derivative of an implicit function. And then we'll work a problem involving velocity and acceleration. All right, so let's get started. So the derivative of a function is called the first derivative of the function. The derivative of the first derivative is called the second derivative. And since the second derivative is a function, we may find its derivative, which is called the third derivative. And you can continue to find the derivatives, fourth derivative, fifth derivative, and so on, and provided each derivative is defined. The second derivative, third, and so on are known as higher derivatives. And here's some notations. These examples here, the notations are for the second derivative. You've got y double prime. Here you've got derivative of y, the second derivative of y with respect to x, f double prime of x, and the second derivative of y with respect to x. They all mean the same thing. It's just different notation. The ones that you'll see mainly will probably be like this one, and this one. Okay, this one's not as common in the calculus classes. You'll see it in differential equations and stuff like that. But these are the notations, and like I said here, similar notations are used for other higher derivatives. All right, so let's work a couple of problems where we find all of the higher derivatives. All right, so in this one, they want us to find the higher derivatives. So what they're wanting us to do is they want us to keep finding derivatives until we get to zero. Okay, so let's go ahead for this function here, y equals 5x cubed minus 2x. Let's find the first derivative of that. So that's the power rule. So we get what? 3 times 5, that's 15. Subtract 1 from the exponent. That gives us a squared minus, and then the derivative of 2x is 2. So that's the first derivative. Now we'll find the second derivative. So we use the power rule here, so that's going to be 30x, and then the derivative of 2 is 0. And then we'll find the third derivative, so that's going to be f triple prime, and the derivative of 30x is 30. And then we find the fourth derivative. Now, pay attention here. For the fourth derivative, we don't do that, okay? We use the primes all the way up to the little marks here, all the way up to the third derivative. But once we get past the third derivative, we write it a little bit different. So to represent the fourth derivative, we'll do the fourth derivative, we'll put the 4 in parentheses here. And then the fourth derivative, so the derivative of 30 is 0. And that's all they're wanting you to do here, is just keep taking derivatives until you get down to 0. All right, so let's look at another one where we have to do that. All right, so I've got f. I've got f prime of x is equal to, now for this one, I need to use the product rule. Okay, let's use the product rule. And then I'll come back and I'll do it a different way and show you another way you can do it. But first, let's just start out using the product rule. So the product rule is the derivative of the first term, which is 1, derivative of x is 1, times the second function. So it's the derivative of the first function times the second function, plus the derivative of the second function. Well, the second function is this x squared minus 1 squared. So I've got to use the chain rule here. So that's going to be 2 times x squared minus 1, and subtract 1 from the exponent, so that's to the first power. and then times the derivative of what's inside the parentheses. So times 2x. So this is the derivative of the second function. And then times the first function, so times x. So I get f prime of x. Okay, I'm not taking the second derivative yet. I'm going to go ahead and simplify this a little bit. All right, so one thing I want you to notice here is that we have a common factor of x squared minus 1. So what I'm going to do here, I tell you, well, let's go ahead and do it. I'm going to factor out x squared minus 1. So I've got x squared minus 1, and that's going to leave me. So if I take a x squared minus 1 out, I'll be left with x squared minus 1. Okay, be left with one of them. Plus, and then if this x squared minus 1 comes out, I'm left with 2 times 2x times x. So that's going to be what? 4x squared. All right. And so I get f prime of x is equal to x squared minus 1 times, that's going to be what? 5x squared minus 1. And then for this one, we could use the product rule again if we wanted to. But how about we do this? How about we go ahead and full this out? So that's going to be 5x to the 4th. And then that's going to be what? Minus x squared minus 5x squared. So that's minus 6x squared and then plus 1. All right, so now let's keep taking the derivative of this until we get to 0. Okay, so I've got f double prime of x is equal to 20x cubed minus 12x, and the derivative of 1 is 0. And then I have f triple prime of x is equal to 60x squared minus 12. And then I've got the fourth derivative. So the fourth derivative, remember we used the little parentheses with the number in it. That's going to be 120x. And then the fifth derivative would be 120. And then the sixth derivative would be 0. All right, so what I want you to see here, and I'm not going to work the problem all the way out. I'm just going to go ahead and set it up, and then you can take the derivative pretty easy after that. So the f of x equals x times x squared minus 1 squared. So one thing we could have done first is we could have went ahead and multiplied all this out first. So that gives us f of x is x times, and then we full this out, so that's going to be x to the 4th, and then negative x squared minus x squared is minus 2x squared plus 1. And then I get f of x, distribute the x, that's going to be x to the 5th minus 2x cubed plus x. And then what you can do is start here and start taking the derivatives. Okay, so that would be another option. All right, now let's look at this problem. Evaluate the second derivative for x equal negative 2. All right, so let's see what we get here. Now, to work this problem, I could use the quotient rule, right? We could use the quotient rule, derivative of the numerator times the denominator minus the derivative of the denominator times the numerator, all that over the denominator squared. And that would be perfectly fine if you did that. But look, if you're having to find the second derivative, third derivative, or something like that, you know, once you take the first derivative, you got to keep going. So try to make it as easy on yourself as possible. So what I would do here is I would take this and rewrite it as 2 times 1 minus x to the negative 1. Remember, this is like raised to the 1 to the first power. And so when you move it up to the numerator, it changes the sign of the exponent. So now let's take the derivative of this using the chain rule. And so I'm going to get y prime, so the negative 2 comes down, so the negative 1 comes down, so negative 1 times 2 is negative 2 times 1 minus x, subtract 1 to the negative 2, times the derivative of what's inside the parentheses. So the derivative of 1 minus x is negative 1, and so I get y prime is 2 times 1 minus x to the negative 2. Now, notice I didn't bring this down, okay? Notice I didn't bring this down. I didn't rewrite this as 2 over 1 minus x squared, okay? Now, if that's all you wanted was the first derivative, then you would go ahead and write it like this. But see, I need to find the second derivative, so I'm going to leave it in this form because it's easier to take the derivative rather than using the quotient rule. All right. So now we've got the second derivative. The negative 2 comes down, so negative 2 times 2 is negative 4 times 1 minus x, subtract 1, negative 3, times the derivative of what's inside the parentheses, so times negative 1. So I get y double prime. Well, negative 1 times negative 4 is 4. And then I'll go ahead and move this down to the denominator. So that's 1 minus x cubed. So that's our second derivative. Now, what do they want us to do? They want us to evaluate the second derivative at x equal negative 2. So I get y double prime of negative 2 is equal to 4 over 1 minus negative 2 cubed. So y double prime, well, y double prime of negative 2 is equal to 4 over, and then 1 plus 2 is 3, and 3 cubed is 27. And so that's the answer they're looking for. All right, let's have a look at another one. All right, so here, find the second derivative for the implicit function defined by 2x squared plus 3y squared equals 6. All right, so when I'm making this video, it's assumed that you've already covered implicit differentiation. Okay, so if you haven't done the implicit differentiation, I've got some videos on that. Go and watch them, and I go into more detail about doing it. So let's find the derivative of this. So that's going to be 4x, right? The 2 comes down, subtract 1, plus the 2 comes down, so that's 6y, subtract 1, and then remember it's times y prime equals 0. So now I need to solve this for y prime. So I get 6y times y prime is equal to negative 4x. And so I get y prime, and I'm going to divide both sides by 6y, is negative 2x over 3y. All right, so that's the first derivative. Now I need to find the second derivative. So let's find the second derivative. Well, to do that, I have to use the quotient rule. All right, so the second derivative, and I'm going to go ahead and just leave the negative out front. So the second derivative is the derivative of the numerator, which is 2, times the denominator, minus the derivative of the denominator. So the derivative of 3y is 3, but then remember, times y prime times the numerator. And this is all over the denominator squared. All right, so now let's kind of clean this up a little bit. So I'm going to get y double prime is negative, that's going to be 6y minus 6x y prime over 9y squared. All right, so now I need my answer in terms of x and y, okay? But the problem I have is I have this y prime right here. So what I can do is I can say y double prime is equal to 6y minus 6x times negative 2x over 3y over 9y squared. So all I did there is I took what y prime is and I plugged it in. That's all I did. Okay. So let's see what we get now. So y double prime is equal to 6y minus, now let's see, well, that's going to be what? Plus, and then this and this cancel, I'm left with 2. So that's going to be 4x over y over 9y squared. All right. So now we need to kind of simplify this thing a little bit. So what I'm going to do is I need to multiply everything by the common denominator. See, look at this as being over 1 and this as being over 1. So I'm going to multiply each term by y. And that is going to give me 6y squared plus, what is that, 4x. Yep, I'm sorry, I messed up, didn't I? This x times x here should be an x squared. So that's 4x squared over 9y cubed. All right. So this is what we've got so far. So what I'm going to do is I'm going to come over here and I'm going to erase this over here so I can have some more room. I'll pause while I'm erasing. All right, so let's just rewrite this up here. Y double prime is equal to, I'm going to rewrite this, but I'm going to go ahead and write it with the 4x squared with the x term first. You don't have to, but you know, mostly when you see problems, the x terms first. It's not wrong if you don't do that, but anyway. So let's look at this. So now what I can do, well, you can see I have a common factor of 2 here. So that's y double prime is 2 times 2x squared plus 3y squared over 9y cubed. And so, well, that works out nice. So now I have y double prime is equal to 2 times 6 over 9y cubed. All right, so pause the video and think about that for a minute and see if you can figure out where this 6 came from. Okay. So where this comes from is, you see the x squared plus 3y squared? Well, isn't this 2x squared plus 3y squared? And what does that equal? That equals 6. So that's where that comes from. All right. So now we get y double prime. Well, let's see. That and that cancel. I'm left with a 3 and a 3. No, I'm sorry. A 2 and a 3. So that's going to be 4 over 3y cubed. And there is the second derivative. And what I realize now is I have forgotten my negative sign, and that would be negative. Okay, so lesson there, don't forget to bring the negative sign with you if there is one. All right, so now let's look at instantaneous velocity and acceleration. So instantaneous velocity is the time rate of change of the displacement, and the instantaneous acceleration is the time rate of change of the instantaneous velocity. Therefore, we see that the acceleration is found from the second derivative of the displacement with respect to time. All right, so all that is if you have a displacement function and we typically represent that with the letter s, so that's s of t. Then the velocity, which we'll call v of t, is equal to the derivative of the displacement function. And the acceleration, which we represent with a of t, that is the second derivative of the displacement function. Or you could also look at the acceleration as being the derivative of the velocity function. Okay? So that's, displacement function, velocity, acceleration, so on. All right, so let's take a look at this. All right, so it says for the first 12 seconds after launch, the height s, which this is our displacement function, s, in meters of a certain rocket is given by s equals the square root of t to the fourth plus 25 minus 50. Find the vertical acceleration of the rocket when t equals 10 seconds. All right, so let's go ahead and write this down. So I've got s is equal to the square root of t to the fourth plus 25 minus 50. So I need to find the acceleration. So I need to take the first derivative, which that's going to give me the velocity. Okay, that's going to give me the velocity. So how do we do that? Well, there is a shortcut for finding the derivative of a square root. I'm going to use that here. So I'm going to go ahead and write this as velocity, which is the derivative of the displacement function. Okay? So there's a shortcut, and I have that shortcut in several videos where I do that, and I also have a video on its own. If you search my channel, shortcut for finding the derivative of a square root, I go into more detail there. But I mean, it's really simple. So this square root that we're taking the derivative of, that goes in the denominator, t to the fourth plus 25. All right, that goes in the denominator, and it's multiplied by 2. That's every time. Okay, and then the numerator, what goes in the numerator? Well, what goes in the numerator is the derivative of what's underneath the square root. So what's the derivative of this? 4t cubed. And so I get v of t is equal to 2t cubed over the square root of t to the fourth plus 25. All right, so there's the velocity. So now I need to take the derivative of this to get the acceleration. So the acceleration is, well, here I need to use the quotient rule, don't I? So it's the derivative of the numerator, so that's going to be 6t squared times the denominator. Okay. Oh, and I know I didn't mention this before, but then we take the derivative of 50, which that's 0. Okay, so it's not there. All right, so it's the derivative of the numerator, which is this, times the denominator, minus the derivative of the denominator. So let's use that shortcut on this again. So that's going to be 2 square root t to the fourth plus 25, and then the derivative of what's underneath the square root goes in the numerator. So that's 4t cubed. Now keep in mind, this shortcut here, this only works on square roots. It does not work on cube roots, fourth roots, and so on. All right, so that's the derivative of the denominator times the numerator, which is 2t cubed. and all this over the denominator squared. All right, so I need to see about simplifying this sum. So I get a of t is, let's see what we've got. We've got 6t squared times the square root of t to the fourth plus 25 minus, now let's see, this 2 and this 2 will cancel. So that's going to leave me with 4t to the sixth when I multiply those. Yep. Over the square root of t to the fourth plus 25, and that's all over t to the fourth plus 25. Okay, because when you square the square root just goes away. All right, now, I mean, all they want us to do is evaluate this thing at 10. So I could just plug the 10 in and punch it in my calculator and see what happens. Or I can simplify it some more. Let's try to simplify it some more. Give us some good practice. All right, so what I want to do is look at this as being over 1 and this as being over 1, and I'm going to just multiply everything by the common denominator. Okay. So that's going to give me a of t. Well, when I multiply this times this, I'm going to be left with 6t squared times t to the fourth plus 25 minus, and then look, that and that cancel, so minus 4t to the sixth over, and then this is going to be, well, this is like what? To the 1/2 power, and this is to the first power. We're multiplying, we've got like bases, so that's t to the fourth plus 25. And then if I do a 1/2 plus 1, that's going to be a 3/2 power. All right, so now that's going to give me a of t is equal to, okay, so this is 6t squared. So that is going to give me, if I distribute, that's going to be 6t to the sixth plus, and then, oh goodness, let's see, 25 times 6. 25 times 6 is 150, so that's 150 t squared minus 4t to the sixth over t to the fourth plus 25, and that's all raised to the 3/2. All right, so let's come up here. So we've got a of t equals, so that's going to be what? 2 t to the sixth plus 150 t squared over t to the fourth plus 25 raised to the 3/2. All right, and if you wanted to, you could factor out, 2t squared if you wanted to. That, I mean, really, it would be good to do, to see if something canceled, but, nothing's going to cancel, so, you can just, just maybe leave it like that. But now what we have to do is evaluate this thing at 10. So I get a of 10 is 2 times 10 to the sixth plus 150 times 10 squared over 10 to the fourth plus 25, and then that's raised to the 3/2. So I'm going to get, all right, so that gives me 20, I'm sorry, not 20. It's going to give me 2.01. And there's, whoop, let me make the box a little bit bigger. Now we got to put the units. Okay, so I get 2.01, and we're in meters and seconds. So that's acceleration. So that's meters per second squared. All right. So I hope the video helped. Check out my other videos. Give me a like, share, and subscribe. And thanks for watching.